Okay, hi everybody. So I'm going to talk to you about the Trustable Software Framework. Some of you have already seen some of these slides and heard this talk already, but bear with me. I'll try to add some new things this time as well. So I'm Paul Albertella. I work for Codethink. We're a company based in the UK, but we international customers. Focuses on open source software, software services, software consultancy, and solutions. And we've been trying to wrestle with the problem of open source and safety since about 2016. So Trustable as an idea, as a project, started around 2017. And we've been building on what we learned by thinking about it and discussing it with various other people in the industry at that point. And that's kind of how we've arrived at the Trustable Software Framework. We've just donated the Trustable Software Framework to the Eclipse Foundation. We've been working on it in public since February when it was announced at FOSDEM, but it's now been approved as an Eclipse Foundation project, so we'll be migrating our work into Eclipse. I'm also an ELISA TSE member and been chairing the open source engineering process group. So, what is the Trustable Software Framework? And I guess also, why do we need it as well? Why do we need yet another way of doing things? So what it is, and really I think how we arrived at this was that in addition to just explaining how do you satisfy the standard, we actually realized we needed to think about it, think about what evidence we needed to satisfy the objectives of the standard, but also to satisfy ourselves that what we were doing made sense, that actually we could trust it and believe in it as something that we could use in a safety context. But we also needed a way of managing the evidence that we're using to support the claims we make. And this is what it really boils down to. We're making a claim that we can achieve some safety objectives, but we're also making a claim about the software itself, what it can do, to what extent it can do it, so what performance characteristics it might have. We wanted a way of organising that information, both so that we could present it to, say, a safety assessor, but also so that our engineers could engage with it, understand what they were trying to accomplish, and link that to the evidence that they were creating. But also we wanted a framework for evaluating risk, because ultimately this is what safety is about. It's about saying there's a risk that this can happen, there's this risk, using this, how do we manage that risk? How do we mitigate that risk? And critically, we also wanted this to be something that we could do as part of a continuous delivery process. It wasn't enough to just be able to say, we've shown on paper once that this software is great. We actually wanted to be able to continue to make those claims as it's changing, as we're expanding it, extending what it can do. And the reason for having a new way of doing this was that we've talked about this already. Software in critical products is increasingly complex, and it's rapidly changing by design. So it's not designed to be you make it once and then you try to avoid touching it. It's intended to have updates. Open source software is increasingly ubiquitous. It's used in products, but it's also used to make the products, and so we have to actually have some way of factoring it into our thinking about this. And importantly, this existing safety standards really weren't developed with either of those things in mind. There's been some attempts to kind of work out how open source fits into the landscape, how we can apply the existing standard to them, but actually it's increasingly hard. And also we've been conscious since we sort of kicked off the Trustable Software discussion that safety is one part of this, but there's also security. And also, you're always going to be thinking about other aspects, other risks associated with your product, even if those are only the kind of commercial risks, the risk that actually you're going to be able to deliver a release on time, that you're going to be able to satisfy some external requirement in that way. And the real question is it really suitable for safety? And we, I think, just earlier this week, shared this baseline safety assessment by Exeter, which was explicitly looking at how we're using TSF to make our safety case, how we're using it to organize the way we're doing the engineering, and how that then allows us to express what the software engineering processes we're using are accomplishing, what they're intended to accomplish, how that actually lends itself to supporting the goals that are expressed by the standards. And in this case, we're looking at IEC 61508. And we wanted to actually be able to, rather than just saying, look, here's an announcement, Exeter have said we're good, we wanted to actually share the assessment with the world, so they can actually see what the basis of that reasoning is, and what Exeter was saying about it. Whoops. So, talked a moment ago about the different factors we want to consider here. We're thinking primarily about safety and security, but also it's important to note that getting a certificate only covers part of the safety space. Functional safety itself only covers part of the safety space. And there are all these other interacting risks that we want to be considering. So our goal with Trustable was to be able to think about all of these risks, not least because they interact with each other. And if you're having to balance, I need this to be safe against, I also need this to be secure, and I also need to deliver these features, then you need to be able to actually think about all of those things at once. So ultimately, this is about providing evidence to make informed decisions about risk. And on what we really trying very much to emphasize here is this about being as transparent as possible. If we want to convince others that they can trust something, we actually need to show them the evidence for that, and also our reasoning for why that evidence supports it. And the kind of final point on this slide is we're talking about trustable here rather than trusted or trustworthy. We're not saying if you follow these steps, you can trust the software. It's saying if you follow these steps, you have the evidence and the reasoning that you can then decide whether or not you trust it. Because whether you trust it will depend on what you want to use it for, what your kind of expectations about risk are. So it's a decision that someone consuming this or integrating it into a product needs to make for themselves. And again, part of what's informing this is we've got a changing risk landscape. ISO 262 was kind of based on the best practice at a point in time, and so it enshrines a set of processes and engineering thinking that was relevant at that time. But that was principally relevant for a microcontroller scale software system. It's kind of extended about a bit beyond that, but the type of risks and the type of complexity involved that we're thinking about has expanded enormously since then. You can see how that kind of dot up there in the top corner. For our projects, we're up there. We're not just thinking about one ECU, we're thinking about multiple ECUs interacting and together providing a safety element. So we're in a different thing. We're not in Kansas anymore, is what my boss would say. But it's also a complex risk landscape just at the software level, because we aren't just thinking about a single piece of software going onto an ECU, or even just a kind of an individual collection of them. We're also thinking about the development environment that we're using to create that software, to build that software, but also to test that software. There's risk inherent in all of these different areas, not just in once you get onto into the car or into the plane or whatever. Now the nature of the risk is different in these different cases, and we might use different techniques for managing it, but we want to think about all of those things, all of those aspects. And so the idea with the Trustable Software Framework is to provide us with a common frame of reference for this, both for thinking about it, but also for comparing what we're doing with a standard or with what other projects are doing. Because if we're doing this in an open source context, we can look at other projects, we can learn from how they've approached it. If they've identified a risk and we're not paying attention to that risk, then there's a gap in our thinking. And in first instance, we're explicitly using this alongside existing standards. We're not saying this is replacing a safety standard. It's allowing you to express how you're thinking about the problem, how your solution can actually satisfy that safety standard. And so part of the design here is being able to map the objectives we've identified to the objectives in the standard, and show the reasoning about why they match. So what do we mean by a framework? Framework is a term that you kind of hear bandied around meaning lots of different things. So I wanted to just be really clear about what we mean here. The idea is that we're providing a set of objectives that are defining what's important for us, what is it we're trying to accomplish. We're using a model which gives us a simplified description of a more complex system, which is going to focus on specific elements or relationships. We're defining a set of methods, methodology, which we're going to use with a particular set of activities, and there's actually making use of that model and other models as well. And the framework is bringing all that together, providing a set of practical structures and tools to help you apply these methods, while allowing you flexibility about how you do that. Because we're not trying to prescribe a particular way of doing things here. We're trying to say this is a way for you to manage an aspect of what you're doing and show how your engineering methods, how your approaches actually help you to accomplish those goals. So this is the set of objectives which you may have seen before. We started with an initial set of 6 objectives called tenets, and we broke those down into a set of assertions. And those assertions are some specific tests, if you like, or thought exercises to say what specific things do I need to accomplish in order to achieve these higher level goals. And these assertions are based on Codethink's sort of specific experiences, but also the best practices that we've seen in use, that we've applied ourselves, that have actually helped us to deal with these particular, to achieve these particular objectives. And then the model is really giving us a way of thinking about the problem, about reasoning about software based on the behaviors or the properties that we're expecting from it, the claims that we're making about it, and the evidence that we're using to support those claims. So it tries to be as simple as possible. It's not like SPDX, where SPDX is trying to represent a very rich set of data and allow you to think like do that. It's
actually SPDX isn't trying. SPDX is giving you a language to represent this.
Absolutely.
Actually, any graph, so what's going on there completely can be represented in SPDX.
Exactly. What I was trying to say was that SPDX is an example of you saying, right, here's a way of expressing this rich set of data, all the types of data. Whereas we're saying, what are the basic building blocks just to express claims?
And we're just basically saying that you can use SPDX for this purpose completely. It can do more.
That's
but
it.
I would just say
they're not
everything.
They're not alternatives looking at the same thing. They're 2 different ways of framing the problem, coming from different angles, and I think they're entirely.
No, but like I say, I think you're an instance of data that could be represented in it, as opposed to different angles.
Absolutely.
We're not trying to.
Yeah. You could use SPDX as a language to express what you have with Trustable, for example.
Yes, you could.
And just keep it to the subset of SPDX that does that.
Okay. We'll come later to
Okay.
to what the thinking behind this. So part of the thinking behind this was we wanted to keep the way of expressing this as simple and easy as possible, so that we're not conforming to a particular standard or using a particular way of expressing things, expressing data. It's more about expressing the ideas, the claims that you're making in relatively simple language. Most importantly, in language that the people interacting with those statements are best able to understand. So that may actually be, the engineer wants to think about the problem in a particular way, we can express it in language they're going to understand. Stakeholders want to think about it in another way, to express it in a language that they can understand. But we need both of those forms of expressing it to be accessible to people at lots of different levels. And another big part of this is the idea that you're going to organize these statements that you're making and the evidence that they're going to into a graph, so that you can see the relationships between them, but also you can use that way of expressing it to do some interesting things, using really some very basic maths, but some maths that lets you kind of build on it and do some really useful tasks. And then building on this model, we've got a methodology, which is about how you're actually applying that model and the objectives as part of a project, as part of the engineering that you're doing. And this is very much intended to be applied in context, and that means in context of a project about which you're making claims. What I think could be used in a safety context, or a project bringing together a lot of components to make a system about which you want to make claims. But being able to kind of bring those two contexts together is the challenge, and this is the idea of a safety element out of context is kind of an example of the kind of objective here. But this is trying to say, well, how do you practically marry, I'm making claims over here, I have some needs here, how do they fit together? More importantly, where are the gaps in the evidence that I would like to see from here, but I actually need in this context? And so the fundamental principle here is you're mapping some claims and evidence up to the trustable objectives, but you're also documenting objectives of your own, which might be, I want to satisfy these objectives for safety standard, but they also might be, I need the software to have this performance characteristic, or be deployable in this way, or whatever. It's always going to be very much specific to the software, or specific to the project in which you're integrating that software. And you might link some of these objectives to requirements or evidence managed in other systems or contexts, but it's also intended that you can use this as a way of managing your requirements at a given level. And you then map your trustable and your project specific objectives to the evidence, and then you can link those to whatever standards or regulations you're actually wanting to satisfy. So I'll go quickly through the objectives just so you can understand the flavour of what they are. We can come back to it later if you want, but I'd like to get to the point where Daniel can talk about how he's been starting to try to apply Trustable Software Framework in a real project. So, I mean, what do people think? What do you actually need? What evidence would you need if you wanted to trust something? What's the most important thing for software if you want to trust it? Any thoughts?
I gave a presentation about it yesterday.
Okay. Exactly. What is trust based on? That's Igor explained in wonderful detail about what he thought would be a good basis for that. So we broke it down to 6 things that are high level. The first couple are very much based on how you're assembling your software, what's going into your software, how you put it together. After that, it's about how you actually manage to change to that software, because we're expecting it's going to change, whether that's fixing bugs or updating it, maybe updating it to apply fixes that have come to you from upstream. But in order to understand whether those changes are good, bad, or something you really want to avoid, you actually need to know what your software is supposed to do and what it must not do. And that's fundamental to kind of the understanding of this. And then when you know what it's supposed to do, what it's not supposed to do, you actually want some results showing you that. But those results can come from a number of different sources. So testing is obviously the main part of that. But there's also other things, like, for example, the kind of the analysis that Igor was talking about yesterday. If you don't actually know, if you're not actually able to engage with those results, understand the limitations of those results, how we're measuring the accuracy and the effectiveness of those results, then they're not very useful to us. And we apply the same thinking to testing, but we also might apply the same thinking to, I'm gathering field data from the software in a deployment state, and looking at the trends there, looking at well, if we actually had a failure in that context, then actually being able to use that information to inform how we're doing our software is going to be really important. And as I was saying earlier, you're starting with these tenets, we're breaking them down into assertions. The assertions are a set of more specific objectives. They're not expected to cover absolutely everything. There are some examples of best practice that we think are really important. We'd really like other people to add to these, say what else you need to accomplish those higher goals. Provenance is about understanding your supply chain, and you might not think you have a supply chain if you're just a small software project, but you do. you're consuming all sorts of packages, being able to control where those packages are coming from. If you're just manually installing them, then you really don't have them under control, particularly if you're just pulling the internet. But also having identified all those things that you're dependent on, those inputs to your project, you actually want to understand what kind of risks they might be bringing into your context. You think about, if I'm using this, have they already identified some flaws in it? How do I take account of those? But also, have I thought about it? Because if I'm using something, I must have some rationale about why, and I'll need to really have at least thought about what kind of risk it might be bringing. And then actually building your software is very fundamental too. For each release of your software, you need really for that release to be at least repeatable, but ideally reproducible, to confirm that you've got control over all your inputs. Otherwise, you might have an input that's sneaking in there that you're not aware of. And you want to apply the same principles to tests as well, because if the tests are part of why you're trusting your software, you need to be sure that actually there aren't flaws in your test, or there aren't some software injecting and influencing the results of your tests. So you need to be able to recreate your test environments as well as rebuild your software. And I said you want to do this, confirm this for each release of your software, but really you need to be doing this for every iteration of your software. And that can be quite hard for some things, because in some cases, tests and the kind of analysis that you need to do will take a longer period of time. But if you're building up that evidence and applying that on a release by release basis, then that can give you a complete picture. And actually managing the changes to your software and the changes to all of your dependencies is very, very important. Not just for fixes, but also for updates, because we are going to want to take advantage of improvements in dependencies. But also we're going to be incorporating updates to our software. This isn't something where we're going to make it once and that's it. We're expecting it to grow and change over time. And if you're not applying the same controls to all of these things and coordinating changes with, for example, the tools you're using to build your software and the dependencies for those, then you're going to risk actually identifying those integration problems later, where probably at the least convenient moment. Expectations, we kind of use this word to avoid the word requirements, not because we hate the word requirements, but because the word requirements can cover such wide territory, and it means different things to different people, and we wanted to kind of draw a line under that. What is it that we're actually expressing expectations about? It's what the software is supposed to do and what it's not supposed to do, but also it's how it deals with things that can go wrong, because that may actually be not something that's designed into your solution, but something that can happen, and you need to know when it's happening and how you actually deal with that when it does. And being able to enumerate the types of misbehavior you thought about is fundamental to this. Talked about this a little bit yesterday, is identifying the failure modes or the particular hazards that apply, and how you thought about them, how they are factored into your thinking about your software. And given that I don't think we'll be able to control and describe deterministically complex software at this level, we really need to be thinking about other things that we can look at, which are indicative of misbehaviors that haven't manifested yet. We really want to detect a problem before anything breaks. And that applies not just to your software where you're testing it, it also applies to your testing processes as well. If you can watch indicators that your tests are somehow something strange is going on and you're not quite sure why, that's a signal you should be looking at it. And then really you're going to need to be able to collect this kind of information in the field, in the actual deployed state, so that you can give somebody another piece of software or part of your software that's implementing a mitigation, a way to deal with that problem, give it the time to do that, give it the opportunity to deal with the problem before it's too late. And then finally, there's constraints. So we're always going to be thinking about ways in which your software is going to be used. If you don't record those, express those, then your users aren't going to actually understand what what assumptions inform your reasoning, and also what the limitations of the software, how and when it's intended to be used. And then results, again, test results, but also data that you're collecting about the testing, data that you're collecting about the construction as well, data that you're testing from, you're collecting from in the field. But also, how are you validating those? Why do you believe those? Why do you trust your test data? Why do you trust your tests? If we're not actually able to use fault injection to create the conditions in which it should fail and confirm that it actually does fail, then you haven't necessarily done all the thinking around your testing. And this is also about analysis of worst case. How do you set about analysing that data? It's one thing to say, well, we collect all this data and we have a look at it, but that doesn't really tell you very much, other than that you've got somebody who may have a set of skills that they're applying to it, but really we'd like to actually express the methodology, the objectives of looking at the data, what kind of patterns you're looking for. And then finally, really, this is ultimately about why am I confident in this? Why should I trust this? And thinking about how you're expressing that confidence, how you're measuring that confidence is really fundamental to this. Because if you're thinking about that as you're going, you are able to say at any point in your project, why do I trust this? To what extent do I trust this? And if you've got some gaps there, you can say, actually, I need a way to better trust this. I need a way to improve my confidence in this. So thinking about measuring against the trustable objectives, but also against your own objectives, and then how you have confidence both in the measurements you're collecting and how you're using them is part of this problem. So the objectives, the assertions are something you want to build out from. It's about you adding statements to this and linking those up to these, but also extending those assertions in the middle of the purple box, extending those wider if they doesn't fit. Question there.
I find it very, very interesting. I'm curious about one thing. The environment of the software.
Yep.
Where would you document that?
Where would you document that? So again, what environment means for a given thing may vary, but to give an example, if I'm building my software as part of the CI pipeline, I'm building that on a server, I'm building that in a software context. If I can actually build and apply the same kind of build strictures to that context as I do to my software, then I'm able to reproduce it, I'm able to reason it, I know what's gone into it, I can precisely control the versions of the tools that I'm using to build the software. And that's one environment. And for a test environment, again, you want the same things. And in some cases, you're setting up the environment to reflect a particular test scenario.
Precisely. So it would be interesting to have on every main branch an environment tag. So I mean, what is the environment of my design? What is my environment of my runtime? What is my test environment? Because otherwise, it will end up in a no-code position.
Yeah, this is all this is standard configuration management that people need to see.
Yes.
And so the question is how to basically encapsulate it in ways that it's predictable to understand where to find it.
Precisely. And so you can extend this graph to include all that kind of detail if you want to, or if you're already managing it in another way, you've already got the configuration management system up there. The idea is to express why you trust that, how you verify that that's actually doing what you think it's doing, why you believe that it's controlling your configuration in a sufficient way.
I think, I mean, the way I see this is that, so right now you have, if you look at the tenants, you have tools are provided to build XYZ, right, for trusted sources. However, that tenant exclusively focus on tools that are used to build a binary image, basically. Whereas I think what is missing here is the evaluation of the tools in general that are used to build the whole safety case, if you will, the whole set of evidences, including the binary image.
Absolutely.
So
Exactly.
it's I think this is.
I think you're absolutely right. I think the tenets are expressed in a way that reflects how we thought about them to begin with. Their scope may have grown, and actually their scope, as far as you're thinking about it, may apply. So coming up with new wording for this absolutely, you know, I'm really, really
That's
happy.
what Paul said, this is an open source project.
Yeah, yeah, yeah.
Pull requests go
The reason it's open source.
The other thing, the other data point I'll just give you is the term provenance
Mhm.
is overloaded as well.
Yes, I agree.
So I'm thinking coming up with a different concept of provenance so that you can capture without the baggage, the same way you've done it with expectations as opposed to requirements.
Yes,
It's probably going to remove conflict, otherwise you're gonna be talking yourself in
yeah,
circles a
you
lot.
confuse people because they think provenance means one thing and you meant something else.
Comment in a common criteria, very document driven, but they have the notation of assumption, and that is the divide going into analyzing the GCC compiler and the silicon you runs on. But then at least you are aware what you exclude in your
Yes,
report.
exactly.
Is that something you can add here to the assumption tenets? Is it relevant?
So what, how would you, well, yeah, absolutely. I think that's that kind of thinking, if it doesn't fit with the way the tenets and assertions are currently expressed, then absolutely. We'd be really happy for you to suggest that, but also if you kind of, that applies to your specific use case, then yeah, you can add it to your graph, link things to it.
Yeah, I think that most of the problem is that all of that you say there is in a given context.
Yes.
If you came out of that context, maybe that's not valid. That's why maybe it's important to specifically say this is valid in this context, which is basically which is floating around.
Yes, and the other thing that's kind of shaped our thinking about this, and that maybe isn't clear, is that we're thinking about this in the context of a given project. So that we're applying it specifically to a project with a given software software output in mind. The fact that you may actually have a number of different projects that are involved in making that software, that might have other different contexts, is something that you actually need to be able to express in the graph and reconcile as well. Because not everybody's going to take a more of a repo style approach to building this. We've been applying this to a project where effectively we're bringing lots of other software components together and assembling them into a system rather than writing new software there. And so the set of thinking about it would differ in that context than it would in another context. But I think, yes, the context is a really important factor that we need to bring out to be better. Okay. So the other way of looking at this, which one of my colleagues suggested, was that this is kind of a top down. It feels a bit like you must do this, a command and control system. It's not intended as that. It's intended as these are basics. This is a foundation upon which you can build your reason. We've kind of started this off. We've expressed what we think are important for trustable software. We've expressed some of the measures, some of the approaches that we use to actually demonstrate that it's trustable. But the idea is you build on top of that, and you're free to think about what makes most sense for you there. With that, I think I'll let Daniel talk about how he's started to apply it to a project, which is a different sort of context.
Request.
Oh,
Philip, I think
you allow
click a
that.
button.
I mean, it's just basically or to switch off the.
Yeah, if you turn off yours, you can share his.
Yeah.
Okay.
Okay. You guys remember the slide Paul showed earlier with the ISO 26262 in that graph, and you are here in the top right?
Yeah.
In my life, I've always been in that top right position. I'm not an embedded guy. And so in the past, whenever somebody spoke to me about safety, I've learned a bit over the years, so I know where they're coming from now, and it might, whatever these things say and do might make sense for that context. I concede that. I'm nice. But anyways, that's why once I heard about that TSF thing, that's why I leached on that, like, like a leech, because that's the first time ever that I saw something that made sense to where I'm coming from in this world. As a context, and so what I started to do a couple of weeks ago is essentially try to combine two things. So there's a project in the Eclipse Foundation, SDV working group, the U Protocol project. This is essentially an automotive service mesh. But we have a homepage, we have videos if you want to know more, ping us, etc., etc. And so on. Essentially what we do there is already we do quite a few things that hopefully are in some way useful to, let's say, demonstrate certain software quality aspects. We are a Rust project, like no, we're not a Rust project, but we are a project with 43 repositories. And the ones that a colleague and myself are working on are Rust repositories. So for our pieces are Rust, with all the tooling and the goodness that comes with that. We are an Eclipse Foundation project, which means we have a bunch of, let's say, bylaws and process definitions that we adhere to, like, because again, we are an Eclipse project. And so the idea is, the thinking is looking at the TSF context, the framework. Paul just walked through that, right? So there's these tenets that, you know, let's say, ask for or suggest providing evidence and assertions for certain aspects of software, including, again, process, you know, testing, documentation requirements, etc. On the other hand, what I mentioned or touched on, we have a few of those things just because, you know, we can, right? Again, Rust, Eclipse processes, we do requirements tracing already, etc. So we have things there. And now the idea is, because again, the open source, there's like a handful of people working on this who have a lot of things to do that are more interesting than, you know, manually updating Excel sheets, etc. Can we kind of combine these two worlds in a way that's like engineering driven, like that's friendly to what we are doing? So automation, CI driven, etc. And so essentially that's what I started to like play with. And I'll just move over to show you essentially what our starting point is. So this is the latest release that we made of one of our core language libraries in U-Protocol. Forget the details, but essentially the interesting part for this conversation is the release assets that we already collect. Like, and you know, there's the obvious stuff like source code, etc. There's our specification. We have a specification coverage report. We have, of course, the test results for this release run. We have test code coverage reports. We have a very extensive licensing IP report for all of our entire dependency tree and so on and so forth. Those are things we already have. And again, trustable tree tenets can be kind of create at least a starting point to link what we have to what, you know, that tree essentially gives us. And so what I began to build is a two-stage thing. The first one is a little GitHub action that, in addition to uploading these assets to our release, it's now also possible to easily add some metadata to each asset. I'll show you what that looks like in a minute, but you know, I don't know whether I'm good or bad with names, but essentially the transfer TSF transfer files, these extensions, that's the metadata that I'm adding to each of these release things, and essentially that is done in a very straightforward way. So like GitHub action pipeline, our release pipeline specifically. And you know, there's GitHub actions that with a couple of lines allow you to upload a file or something, an artifact to a release. That's what this is, with the little added wrinkle of the last 3 or 4 lines where you know, simply can specify additional description metadata, and again, work in progress. This is a first attempt but for example, IDs of TSF assertions that this applies to, right? That's the starting point. This is all essentially that needs to be done on the release side, and that will give us, or me right now, again, for each artifact that we're uploading, the metadata in those little nice files. I'll show you what they look like in a minute, but that's the starting point. And then the idea is, when we got that, wrong window, sick. When we have that, what we can then do is create another set of CI pipeline actions, or maybe a dedicated trustable release project repo. I don't know yet, we'll see, but right now this is a workspace that I'm just using to play things, to try out things. And essentially what I've done there, let me clean this up again. So what I can do there, obviously, right, this is not rocket science at all, but essentially I can now tell a little script to point that to our project, our release URL, essentially, and tell it to get all that metadata and maybe also get all the reference assets as a first step. And that's what that thing now does. Give it another second or two. That's the Homer Simpson thing again. All right, let me reload this. This is a dev container, so it's not really cleaning up things properly. Let's at least clean and reloads for the second part. So down here we are empty. So anyways, that's that's the same files that you just saw on the GitHub website. But essentially, let's look into any one of those. This is the metadata that the little upload action has generated. There's the obvious things up here, right? Download URL for the file, name of the file, but we also get the description that we put in. We get some kind of categorization if we want to. Again, work in progress to be determined what makes sense here. I don't know yet. We get the TSF IDs that this pertains to, right? Again, so far, so simple. And then the second step of this is to essentially have another little piece of code script that can now go through all of these metadata things that we have for each artifact and just generate automatically TSF statements, essentially. And right now, again, this is extremely bare metal, bare bones. But that is something that is now easy to do, obviously, right? This is the actual file format of the tenets in the tooling in the context of the TSF project. Details if you want to, and Paul is here, etc. But in principle, there's a header and there's the content. The interesting thing about the header in our case right now is that the header is essentially the place where that piece here links to whatever it pertains to, like that chain that Paul showed earlier, statement, assertion, evidence, that's done via those links. And in the body of the statement, I can now essentially just, again, this is the opposite of rocket science. I can simply use the metadata for my little asset manifests and, create a little evidence file. So essentially, the next step that I'm going to have to do is 2 or 3-fold. I did mention initially that a bunch of the tenets, a bunch of the quality dimensions that are mentioned, we will get essentially almost for free, because again, Rust and the Rust tooling ecosystem is fantastic, and there's a number of things, including automation of rejecting a merge request, for example, if there's a security vulnerability in my supply chain, that's all there already, right? And I can use all of that to fill evidence items for the TSF tree. Second part is same idea, what I mentioned. We are Eclipse Project, we have well-defined processes for certain things. Again, we can create a bunch of assertions and evidence statements just because we are in that context. So, creating that's gonna be manual labor. And I will need help for that, but that's one of the things we will do next. And then we go to the project specific part of this. Essentially because what I've pulled up here, that's again a very bare bones.
Yeah, let me just talk about this.
Evidence.
I think this is an interesting example because on one hand, it's a really good example of how you can gather the evidence that you're using to support something automatically. You can do it as part of CI. In this case, Daniel's kind of shown us how you could do it manually, but you can imagine actually that's a series of steps.
That's what
I can automate so that you can bring it together.
Yeah.
Now, one of the things here about actually representing this in an evidence thing, what you've got here is a bunch of evidence to which an evidence item like this can point. And if you have that pointed in such a way that I'm not expecting this to be here in a Git repository here, I'm expecting it to be generated as an output of a CI pipeline. At that point, you then need some way of integrating an automated check. So one of the concepts we've got in the framework is this idea of a validator, which is a script that is fired as part of you checking through your TSF graph to say, I'm expecting this evidence to have been generated by my CI pipeline. Is it there? Now, great, I can check it. Does it have all the things I'm expecting? We've got a list of assets here. Have I actually got those assets? Do they actually match what I've got here?
Yeah.
And then you can use that as a way of double checking it and automating your process.
Yeah.
And then the point about is because if you want to kind of encapsulate all this data, you're going to end up doing a lot of manual changes and committing it to the Git repo and then doing it. And you don't want to do that. You want to be able to say, I'm going to review the process of getting this. That's logical. Now I can trust that this automated way of checking it works for me. And the part that Daniel's alluding to that he's not done yet is that, okay, so I've got this evidence. How does that actually link up to these high objectives? Because it's that reasoning, that's the part that you can't automate. That's the kind of the human input.
Exactly. So a bunch of assertions actually that link the evidence items to the TSF tenets. That's what's going to have to be done.
Yeah.
Right. And again, I will need help for that, but
Yeah.
At the end of the day, it's just work.
So let's say this is kind of bottom-up thinking. It's I already have some evidence for this, which I believe does something. Let me first get that together, work out where that's coming from. Now, how do I actually link this to what I'm doing? And actually, are there some other objectives that I'm fulfilling with this? And how do I express those?
Yeah.
And essentially, just to wrap this up, the idea is obviously, I mean, this is the protocol that I'm applying this to right now. That is not a system, right? That's a building block. That's software infrastructure for building systems, which means what I'm aiming for here is not to have a trustability score like of 100% and then expect people to, kind of put the stamp for approval on and release it in a product. But the idea is that if protocol is becoming part of the supply chain for someone who is building a system, I want to make using us to
Make the evidence available so they can.
I want to make it as easy and as convenient and as complete as possible for the integrator to use our component. And this will still mean obviously that the system guy will have to do a bunch of things, system level things that we can't. But I'm thinking that, if your supply chain tries to be a good citizen and, provide as much as they can, and you can put as much of those things upstream as possible, that's the way to actually do this economically. So what we are going to do here is all going to be automated. There's not going to be like beyond the initial engineering, but for the operations, there's not going to be any manual steps involved once we are at a certain point.
There'll be some
But it
manual
can be
steps
continually expanded, it can be continually improved, and the idea is, just to be an item in the supply chain that you can trust to a certain degree because of bam, bam, bam.
So just to correct you on one thing, there will be some manual steps, and that's
Not for every release.
not for every release, but part of this is to say there are manual steps. I've reviewed this. I've reviewed these tests. I've checked that they're satisfying this thing. Until those change, or until the objective that you're trying to link to changes, you don't need to review those again. So if you record that as part of your graph, you're recording that in your Git repository, the moment one of those things changes, I need to review that again. So the idea is that we know there's manual steps, we know there's human input here. Let's identify it, let's identify kind of the basic concept of impact analysis. I'm making a change, What impact does it have? What do I need to look at? Who needs to look at this? So it's avoiding toil, which is needlessly repeating manual steps, and just focusing on where is my specific input needed and how can I quickly and easily report that, and also gather all the information I need to make that decision.
And we have you, I don't know who was first.
Oh, sorry.
So I'll go. It's an interesting point you make about the manual steps. And don't want you get too caught up on that because I've chatted with both of you about this. And I mean, I work as systems engineer and there is a lot of manual steps anyway. It's just, I think the more important factor is where do you want to spend your time and how do you want to spend your time?
Yes.
I personally, and I don't know for other OEMs, people spend a lot of time going from our requirements management tooling systems over to Excel sheets to then chasing up our developers to checking with our architects. And it is also tedious and prone to error at every stage to prove traceability, to find the evidence. And I have no way, I mean, we aren't as rated, but or QM no, but it's very tough sometimes. And the more complex the system gets, the harder it becomes to actually manage cope with these thousands of requirements. And if the developer actually do it, okay, normally we have testing in place. But I would prefer to spend my time and effort having something that can be scripted and automated
And then
in this manner, because the manual effort is anyway being taken. So
and this gives you a format for trust but verify,
yeah, and
because you
also
should
if
be
the
able
supply
to
chain starts doing this,
recheck the evidence. Yeah,
it just
that's
if the
part of
suppliers
it.
do it, it's even better.
And like this, the two core things, again, speaking from our, I think, cool but somewhat small open source project, we only want to do things once.
Yep.
And we want to do those kinds of things, you know, we want those things done by the same people who are writing the code because they know what the heck they're talking about.
That is the source
And
of
that
truth.
is,
Yeah.
do it upstream,
Not
do it with the
required.
code, and then don't bother again if you don't have to. That's the idea.
That's right. And part of the reason for this, I think, carrying this, starting from this simplified model is that you want it to be something that people can engage with, and they can say, okay, fine, I need to say why this achieves whatever it is you want. What's my reasoning? Why do I think Rust is cool? You know, if I believe Rust is doing all these things for me, let's break that down. Let's actually say, yeah, Rust does this, Rust does that. I believe this because, and then we can build a case for it. But then when you actually get into the concrete, the really important part, which is my software, what is it that you think your software is doing or is supposed to be doing? How do you know it's doing it? And more importantly, how do you know that your methods of knowing it's doing it are actually doing it as well? I think that's it's building out. I mean, use the term knowledge graph. It's this idea of a knowledge graph that has a structure, that has a set of rules, a set of guidelines, but that let you express your thinking, your methodology, your evidence
I mean, with the V model, I don't necessarily per se care what language a developer chooses to develop in. I am the systems side and the verification side of the company. They just care that the evidence and the requirement has been met.
Yeah.
But too often that's not how we work.
Yes.
We work with the requirement as the holy grail, and that's the thing.
And if you say to
be C because or C plus because you can do MISRA and but no, that's the wrong way of thinking.
And if I say
use this as methodology.
if I say to a developer, you must use Rust because I love it, that's fine. But if I then break it down to them and say, we want you to use Rust because X, Y, Z, rather than you having to do all this annoying stuff with demonstrating that your C code is MISRA compliant and then rewriting it to make sure it is. You write Rust and it's already satisfying.
If you use Rust and you can produce evidence easier, then use Rust.
Exactly.
Or if you want to use C and do Mr. C, use that. But the key thing is to produce the evidence.
Yeah.
To prove that the requirements are met, tick, 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 tick.
But
Then
also,
we
if,
can release the software.
exactly, but also if a developer wants to say, no, I can only do this in C because X, Y, Z, then you make the case for why they can do it in C.
Yeah.
And they can say what additional precautions they're taking which still meet our objectives.
Can I tackle something else on language?
Don't forget Gap also.
Let Gab go first.
Yeah, sorry. No, my question is, But do you also intend to, I hope, I mean, I guess you also intend to expand this further to demonstrate, to have asset showing why
Yeah.
all the tests are sufficient.
Yeah, that's the engineering side, and that's what I meant with this manual work that has to go in there. But that's the larger part of the work, and I just started with the low hanging fruit so far.
So you can start at the top and say, why am I doing this? What is it I want to achieve? Or you can start at the bottom and say, what am I already doing? Why do I think that's useful? And then you kind of build in both directions and you can join them together. And then along the way, you identify, hang on, I haven't thought about that aspect. Oh.
That's the trustable traceability KPI. I mean, what would you put things?
So the traceability is statement to statement. So let me switch now to kind of talk about the model. That's where it comes from. I'll skip over why we need it. I think I already talked about this anyway. We kind of come to this basic principle statements, what it is that you're actually trying to achieve, and keeping that really simple. One sentence, a sentence that can be true or false. If you can't falsify it, it's not really very useful. Ultimately, if you can't make a test for it, whether that's a test that you can perform manually to say is this true or false, or a test you can automate, then it's not very useful. And then you're going to link that to other statements to show how it works. So I called it dependencies here, but ultimately what we're saying is, I've got a statement here that I want to show is true. How am I doing that? What sub objectives do I need to demonstrate in order for that to be true? Break down your reasoning. And that does two things. It kind of breaks the problem down into things that you can then link to evidence, but it also says, this is the extent of my reasoning about this higher level objective. And somebody can look at that and say, well, that's fine, but that's only covering 60% of what I actually like to see here. You've missed this. Oh, I'll add another one there. I need some evidence for that too. So it lets you build up this idea about what's there.
And again, in an open source supply chain, that would be the perfect time as user to say, great, give us a pull request. That's possible now, right? We can just
If we could do that.
throw this upstream.
And then the bit that's kind of not in this picture is this: is you're using artifacts to support this evidence. Come back to that in a second, but essentially an artifact is something in your repository or something that you produce as part of your testing or your construction, or something that you maybe produced in the past, a whole data lake full of information about things which you're querying to say, hang on, are my trends going in the right direction? Have I seen this kind of thing before? Whatever the evidence is, you want to link it in to say, I think my statement is true because of this, or you might be qualifying a statement to say, in order for this statement to be met, you need to meet these criteria. They're in this document here, and I've linked to that document. So when that document changes, you're automatically going to get a trigger to say, this statement's changed. If you're linking to it, you now need to check that you're satisfying all its objectives. So this is a very sort of simplistic example from a safety monitor project. I'm starting with the problems at the top and breaking it down, saying, and in this case, it's saying we're saying we think actually all your sources and tools need to be mirrored in your control environment so that you can be sure that they aren't going to change from under you. And the project is saying, well, actually, yeah, we don't think that's appropriate for us because we're just an open source project and we're not interested in applying those. But if you're actually using this as part of a safety system, you need to do that. So it's listing some assumptions of use. Now, some of those could be things that you might want to actually take care of in your project in the future. But right now, I'm expressing my assumptions. I'm saying I'm expecting an integrator to do this. I'm expecting a project using this to do this. And then on the other side, you've got some specific assertions that it's saying, well, we satisfy this by tracking known security advisories for dependencies. And then we know that if those advisories have changed, we actually have an automated process that's going to fail our CI pipeline when that happens. So we'll then have to go and look and make sure that we're taking account of those.
So sorry, can you go back and say? Yes. I mean, so provenance how, no, because I mean, here it's
You're right.
governance broken down between sources coming from sources are traceable basically
Yeah.
into a controlled environment. And the other thing is components or tools are assessed to identify potential risk and issues. And then right below, I only see security advisories for dependency. So
This isn't a complete graph. This is an
just
example.
an example.
This is an example. It's a work in progress, and also it's just an extract I've made of it. Because if I showed you the complete graph, even for this relatively small example, they get big quite fast. But the point of having it in a graph as well is that you don't need to look at the whole graph.
Yeah.
You need to look at the part that you're looking at and understand its relationship.
What we're sort of almost looking at here, and just feel free to cross-check, check if I'm not thinking of it correctly. Is we're looking at a statement of policies to be applied on top of the knowledge graph. A classification system on the evidence in the knowledge graph.
So that's one way to look at it, yes. So if you think of it as a policy, then that's saying you must do this.
Well, no, so
And I'm thinking of it the other way around, saying, this is what I need to be true. How you achieve it is something I want you to explain. So a policy is an evidence, piece of evidence. Well, I'm applying this policy and I'm claiming that that achieves this objective. That's super. Then how do you know it's actually achieving that objective? How do you know that the policy is being applied?
I'm looking at it more from the view of, here's my framework. Here's how I can apply the framework to the nodes such that I can construct the evidence story from it, and then understand whether a policy has been satisfied or not of expressions.
Yeah, a policy, if a policy expresses your objectives, then yes, absolutely.
Okay. Or what should be in place, basically, like, the thing is, okay, there should be no security vulnerabilities in when you're shipping as a policy. Now,
I
how
mean,
do you
that's-
pull all these pieces together to demonstrate that is the
Yeah,
challenge.
That's the idea,
Yeah.
and the other really important thing that we've kind of tried to convey in this is that quite often you see this type of thing expressed as you must have X,
Challenge, yeah.
rather than here's the objective. Show me how far you are towards that objective, because actually you might not ever be able to achieve 100%. You might not ever achieve completeness, but if you can measure your progress and you can say, then say how that's improving your confidence, then that's actually giving you a direction of travel. It gives you a chance of saying, well, actually, what would be the level of confidence I needed in order to say that this is ready.
Okay.
I'll skip over classifying statements. Oh, sorry.
I want to pick up something on something you implied that this needs to all, it will be used in full force when it's part of an integrated product. That's your intention. I wonder, I mean, for an integrator like Volvo, for example, I think it would be very valuable, or it would be interesting before doing something to see and understand in a really visual way how this looks. And these segments exist to one way or another. And so I wonder if it would make sense to have out of context trustability, for example.
That is the entire intent here. It's essentially saying, we know you don't have a complete context. You know, you've got some assumed context. Everybody has them. They might not write them down. They might not express them. They might not even kind of articulate themselves, but you're always assuming a context or a set of contexts. What we're saying here is if you write those down, then that makes it easier for people consuming your software to then say, well, does this fit my context? If you can do that, if you can identify the AOUs, like here, you can make it explicit. I've explicitly assumed that I'm not doing this, but you would need to do this if you were going to use this.
Right, but if on remote is current, it does not exist your environment. There are some use cases. It's not something that would explicitly somebody would explicitly document, right?
It's something that you document, but you don't necessarily document it. It's got to one of the assertions under or above expectations is
Just the other version. Okay, maybe it could be under expectations. Yeah.
Yeah, constraints. So this is what I'm talking about. I'm saying, if you've thought about a particular context or you've made an assumption, express it there. If that's missing, if somebody's trying to use your product, your piece of software, and that's an input they can give you. They say, you haven't said what system, you haven't said that you've assumed that we're using x86 here. You haven't, assumed that this is going to be run in a CI pipeline. Or you haven't assumed that you're using a secure protocol to communicate with this. It's a place for you to express things that you can't satisfy yourself because they're about your context, but you will do.
That's why I reacted to the beginning about the environment. I mean, this is very logical, and setting constraints there without defining the use case is a little bit cause some kind of ambiguity.
Yeah.
And that's why I kind of.
Related to that, I think that maybe it's important to decouple the evidences from what you get from the evidence.
Yes.
Because depending on the use case, the assertions can be widely different.
Yeah.
And there are different actors writing the things. I mean, when I define my use case, I define my assertions that are important for me, and I define this level of whatever.
Absolutely, you're quite right. So this is why we've got this kind of, so we have this 3-level mini model of it, which is saying at the top you've got an expectation, which is basically it's an input to my project. It's not necessarily something that has an origin. It's something I want this, or a stakeholder wants this. And then you break that down into assertions, which you might qualify by pointing it to an artifact, so a document that's expressing it or whatever. Then you have statements which are saying, here is some evidence, and here is how that evidence supports this assertion. What you're saying is actually you might have exactly the same evidence, and the evidence really is these artifacts at the bottom. It's the code, it's the test, it's the result. That particular artifact, that particular output might support multiple different evidence statements in different ways. And the purpose of that separation is exactly that. I'm saying this evidence supports this assertion in this way, and here's the artifact that shows that.
With the analysis, basically what we need is to produce the evidences from the different projects, and then the rest of the analysis would be somewhat automatic, let's say.
So the evidence is something that we ideally want to be generated automatically as much as possible.
I mean, it could be automatically, but it's like a different phase.
Yes.
From some point of view, I generate, maybe the project itself generates evidences in a reproducible way.
Yeah.
And then when I want to do an analysis of a certain system, I just go and get those evidences, contrast it with my assumptions and everything, and produce a result.
Okay.
Sort of the process.
The exact idea here is that the order in which you do those things, how you structure that for your project is going to vary. You might want all of those things to be true all of the time before you allow something to merge. Or you might, as you say, you might build up the evidence, build up the reasoning, and say, actually, yeah, I'm going to review that at the end of the year and see whether it makes sense, because that fits the way my project will.
I'm thinking that specific actors like companies producing an open source project, for instance, they could be interested in producing the evidence themselves.
Yes.
So that to some extent, that could be, let's say, subcontracted to the producer of the software if they are interested in that. Also, third parties producing that evidence for a company or whatever.
That's a really important point. I might, as an open source project, say, here you go, you can use this software. However, you're going to have to run these tests in your system context in order to generate the evidence to show that actually these things are represented. And that gives you that flexibility. And we've talked about those kind of evidence nodes at the bottom without any artifacts to support them as assumptions of use. But there might also be a gap. There might just be that actually I know I need this evidence, but I'm not producing it yet. And it's just kind of a work in progress symbol. I know that I've got a gap here, and that's a problem.
I mean, we kind of work in a way like this already, but it's not so connected.
Yes, and
that's the unique selling point. I think
that is the key here, isn't it?
To connect everything, but all the chaos going in.
This is exactly where it came from. We had this big, complicated project. We were generating all sorts of evidence. We've got all sorts of thinking about it, but it wasn't joined up. We tried to join it up by pointing at bits of the standard, but actually that didn't express the engineering goals that were interesting and the engineering goals that informed and then supported those things. So we needed a way to express that reasoning. Not in just a way that, somebody like me who kind of lost this sort of problem can understand, but the engineers, the testers.
Bingo. People are just throwing requirements out there and
Yes.
missing the assertions that have been made.
Yes, I've lost count of the number of times I've been, given an enormous Excel spreadsheet full of requirements in extravagant detail, and then, oh yeah, I don't actually understand what the objective of these is. I've got all these details,
Yeah.
but I don't know what they're for.
You got a question? Paul?
Okay.
Yeah, I would like to, so you implied now, you came back to standards again. My question is, did you have some kind, did you think of, or you have a path from going to those, from those tenants to this, back to the standards, that you can say, I will have to argue at the end of the day, we are in a world that still requires standards. So have you already thought of this going back to the standards, or is that something that's still open?
Yes, is the answer. So
But I made an or question for that. So I'll rephrase my question.
I will rephrase my answer.
Okay.
Remember the bit at the beginning where I said we got this baseline assessment from Axel that we
Yeah,
published? Yeah.
yeah.
So the part that informed their assessment was, we did a mapping of our way of expressing our engineering thinking, traced to Trustable, against another graph which expressed, here's the objectives of IEC 61508. Here's how they link. And when we were doing that linking, we found a few gaps. There were some aspects that we weren't covering in Trustable that were expected in the IEC 61508. So we then had to say, right, here's the evidence for that. Here's how we link it. We're going to then add a new assertion to our Trustable graph. So we forgot about that. We missed it. And so what I'm really interested in kind of opening this up to the world is, oh, hey, Paul, you forgot that.
Are you gonna share your mapping?
Yeah, that was the question.
Are we going to show up? I hope so. Not today.
Okay.
Not today.
This one is probably a copyright problem, I guess, right?
Well, no, you can always put the numbers,
Yeah.
the sections.
Numbers are allowed.
Numbers
Yeah.
are allowed. You can say this Trustable, this is how we did our spreadsheets in ELISA already.
Yeah.
Yes,
We've gone through this process.
Absolutely. So I can say the intent is there,
Okay.
the timeline's not.
Okay.
Mhm.
Yeah, but that's the idea. So now you map, if I wanted to go over a certification standard.
Yeah.
Then that will be the path. So I will take this graph I have here, and I will point to the standards and try to convince my assessor that those relationships are valid. And if they buy that, then I could go this way to prove it,
Yes,
right? That's
exactly.
the idea. Okay.
Exactly. So you build up a graph, an IEC 61508 graph, and you say, here's how it looks.
The problem is,
26, 26, 2.
sorry, sorry,
I just would jump on the standard because from some announcement, it sounds like Trustable should be a standard. Because it's like this Trustable will be the new standard for safety, and I mean standard has a multiple meaning. It can be like it's like the state of the art, and it's like, I mean, a standard product doesn't mean that it's like it's based on a standard, right? It's like there's multiple. The question is like, is it intended that Trustable becomes like a standard, a functional safety standard?
It's intended that it becomes a way that anyone and everyone can use.
Yeah. So
if standardizing it is a way to give it credibility, then sure. But what I really don't want to happen is that takes it behind closed doors.
No,
So it's
we've
no
already,
longer-
so we have paths.
Yeah.
SPDX is an actual open standard
Yeah.
from ISO that is publicly available at no cost. You
Yeah.
can do this. We have the technology.
But the other part is, having heard from people like Gab about what ISO committees are like, that's not the intention. This wants to be something living, breathing.
This is why there's the paths process.
to me, it looks like a way, an efficient way to already say that within the Eclipse SDV workshop here. So it looks to me like an efficient way to organize a safety case and map it against the objective to the standard. Now, the point is, the pain point at the end is to define the KPIs to justify
Yes.
equivalence to A, B, C, or C, 1, 2, 3. So
But that's something that ultimately, that's where you need your safety assessors.
And that's the system level thing, right?
Yeah.
You need to express what you're doing, how you're doing it, how you're demonstrating your confidence in it. On the basis of that, they can then say, fine,
Yeah.
that meets this level of safety integrity.
But to that extent, going back to what Chris was saying, I've never been much involved with SPDX, but that feeling is that this quite overlaps, right? Because at the end of the day, in both cases, there are ways to organize a safety case. Am I wrong? Or?
Yeah, but I
No.
think this,
Again.
for me, this looks, if you look, if you would set existing safety standards to, for example, automotive spies, this looks to me, unfortunately, a lot like automotive spies started. So please take care that it does not go down the drain like this. But for me, this is, this is this is more the way of thinking.
Yes.
And you could use SPDX still as a language to express this and to get also this glue to the standards and the glue to, you don't even need to go down all this ISO drain with that and say, this is a way of thinking, of approaching things like STPA, approach it like this. And if you want an ISO compliant safety SBOM, do this mapping with SPDX. So that's, I think it's overlapping, but it's also complementary.
I agree. It's
And
about.
so the only fear is please make
No.
sure it don't go,
So we'll go
be
that
the
way
next eight
for one
boys.
reason. It's not prescriptive. It's not saying.
Yeah, I
you've
know,
got to do
the
this.
only
It's
thing that's
also
being
not-
prescriptive is the language in there,
Yeah.
in your YAML file.
Yeah.
Will take people in the direction of creating a standard around that YAML file, and
Yes.
that's where you've caught me, that's why I'm triggering.
This is good input, but yeah.
And there are people in with BAs in business administration that apply automotive spies, and if you have people applying this without any knowledge, this will go down the drain. So please,
yeah.
please make sure
I'm-
that won't happen.
I'm with you. So the important bit is, it's about a way of thinking about it, but the other thing is that it's a way of thinking about it as part of an engineering process, and it
Yep.
needs to be deeply embedded in it. So I've kind of got this whole series, I'll make these slides available afterwards. But this is based around this idea, which is fundamental in a lot of open source contexts, of you've got a pipeline
Mhm.
where somebody's proposing a change. I'm going to build it, I'm going to test it, somebody's going to look at it, and then, and only when I'm happy with it, am I going to merge it. And there's all sorts of evidence and things that are produced on the way. And then when you add in groups of developers, it gets slightly more complicated. And then when you add in multiple production lines that are interacting with each other and they're producing a system, it gets even more complicated. So the idea with TSF was, in the context of one of these production lines, but taking account of the other production lines and how they interact together, express the reasoning in each context. So that actually then finally, in this system context at the top here, where you're bringing all these things together and you're assembling all the evidence, you're able to then say, okay, my assumptions about this are based on this. Here's the evidence, here's the evidence, here's the evidence. Oh, hang on a second, this component over here has changed and that's broken all my evidence. I know where to point the finger.
Just a short remark. We start 10 minutes later and we are 10 minutes over time, just for you to get the rough frame of what you want to hear is the next session anyway, but just want to.
I'm happy to wrap up at this point. I can talk about this forever. So
I understand that we like.
the picture, this just kind of takes you through the methodology. It really is fundamental that this is intended to be encapsulated evidence you're either storing and controlling in a Git repository or generating as part of a CI process. If it's not one of those things, then you really haven't got the framework within which to control these changes and to actually say why you trust this evidence. But also there's confidence scores. I talked about this idea of scoring this to know where you are. There's two types. There's the ones that are coming basically from the people who know it. Your developer saying, how much do I think this is done yet? Or do I believe this? Somebody else has written this, do I really trust it? But also there's the evidence that you can score much more authoritatively, which is essentially saying, if this test passes, then this is true. I've got the test, it passes. And the one at the top is the key here. This is about providing continuous impact assessment feedback. I want this to be available to me as the engineering process is turning. It's not something that I want to do once a month. It's not something I want to do at the end. It's something I want to be doing all the time so I can understand the impact. And I can, crucially, I can add in the reasoning when I'm adding the artifacts.
And refuse a pull request, right?
And the goal being here is that then you can produce reports like this, which are saying, okay, here's my objectives. I've got scores for them. I can color code it. You know, it can show it to a manager and they can say, oh, excellent, yes. This is looking really green. I'm very happy. Or they can say, why is this red, Paul? Well, this is red because nobody lit the requirements. And then there's some tooling to support this as well. We started out with a tool called Doorstop, which had this wonderful property of it was designed to store things as text in Git and then link it to things in the Git there. That was Daniel's part. We've got lots of plans for this. It's, you know, it's very much a work in progress. It's been opened up now. You know, it's not a finished product. We've shared where we are with it. The fact that it was something that Exeter have looked at and said, okay, yes, this is what we want. This, you know, this accomplishes what we're expecting. We like the idea. We like it so much that actually, if you do this, we don't want, you know, and we give you a certificate on the basis of it. You can make changes, provided you're following this process. You can make changes, and you don't need a new certificate. This is kind of making, we talked about this before, certificate as marketing rather than as anything else. The evidence is continuous assessment evidence. The fact that Exeter can then jump in at any point and say, right, we want to audit your process. We can see the evidence, we can trace it through, we can understand that your reasoning here is actually being supported, and that's the basis for it. So the one at the bottom there, I would be very happy for other people to try using this, give us the feedback, tell us what we're missing, tell us if the words clash with other people's understanding. And
So what was provenance?
Provenance
And
is
we also had, I think, hours of discussions about the word attestation. Because this is
attestation,
also something that people crush.
we included a lot of words in here that made sense at the time, but in retrospect.
Realistically, you're gonna be directly up against the intuitive book and their definition of attestation, which has got a certain amount of mind share in the cloud community at this point.
We should just use UUIDs.
Yes, no question. Do you have a way to map those tenets by classes to a requirement, so sorry, to a standard? Because usually in a standard you have different types of activities. So if I'm trying to use this to see for completeness, did I cover all the activities of a certain type? There you have like layers, but I didn't understand if there are vertical partitionings.
That's a really good question. So the reason we describe it as a trustable graph, it's not a tree. The trustable part looks very much like a tree because it's got an origin at the top and everything. But you have interacting trees. So you can have a tree which is coming down from here's IEC 61508. Here's how I've broken those objectives down. I can link across.
Yeah, but my question is, can I understand if I have done all the activity that a certain standard requires me to do?
Yes.
This.
Not from this, no, you can understand this. This tells you how, well, the trustable objectives tell you, have you thought about all the things that we think are necessary for trustable software? If you then make a tree which says, what are the things I need for IEC 61508? And as I say, I hope we can share out.
That's the mapping piece, right?
That's the one.
That's what they've done. It sounds like they've done it. They just can't make it visible to us yet, that they're keeping it inside until appropriate conditions are met. We don't know what conditions are yet.
The problem is that the definition of trustable software is not equivalent to anything system. It doesn't, so, I mean, you can only say we have done everything that is defined by trustable, but that does not imply it is safe.
To me, that's more like a presentation view that can help you to map, to visualize.
Yes,
You have
to organize a safe field.
Yeah, so then the question is.
The analysis method also.
It's exactly, it's a way of breaking the problem down, because one of the problems we've had with safety standards over the years is actually interpreting them in a way that we can do engineering. And this is a way to do that, to apply that thinking, not by starting with the safety standard, but by starting with what are the things
Yeah.
I think are important and how do I actually.
Like what we ended, in some ways, it reminds me of the things about 4 years ago or so when we were doing here's how we're rephrasing what the standard is looking for.
Yeah.
Here is, we've got this big spreadsheet like that right now that we worked on 4 years ago in ELISA. Where we mapped it to what was actually happening in the Linux kernel, what was the evidence in the Linux kernel that satisfied that.
What I had in mind was, could this be a way to speed up the interaction with the assessor? Because usually
Yes.
some of the questions the assessor asks you, they show gaps.
Mhm.
So if you had a template which already asked you basically the same question, then you just fill it and you go to the assessor and say, I filled your template, so.
Yeah, also I love the question about how are you sure you can trust your tests, that your test is efficient? Because when I'm doing an assessment, I ask this question and I get blank faces.
Yeah.
The question back, where does the standard ask for that? And sometimes I get a reasonable answer. So in the end, I always get a reasonable answer. So we go down this journey, but people are not aware that this is an important point for any, let's say,
And that-
rating of a test. You need to be sure that your testing is good and sufficient.
Yeah, and that was the point of making our kind of understanding of what is needed, what is
Yeah.
best practice, it's not all covered in the standards. The standards don't
That-
always prescribe
Not
engineering methods.
Not in a way that engineers understand it, yeah.
So if our ways of describing it don't work for you, tell us, we're improving. If there's things missing, tell us, we'll add them. And in the end, if we don't agree, you can add them to your own graph. You don't have to use our objectives. You can define your own.
What made me a little bit worried is again is the data format. You talked very briefly of what you intend to, but if you are doing a shared project, then in the end, the data format you are using will be the actual real thing that will be shared and has to be agreed upon, because else you will not be able to reuse it. And so how much care did you put into, and perhaps there we go back to SPDX, how much tooling is available for the data format you decided to use? How easy will it be to get that one running, or isn't it that important as I'm thinking?
It is important. We do have formats. We do have tools that you can, we've got documentation you can read. Go to the pointers here, it will talk you through it. As say, we started with doorstop, which could store the information as individual YAML files or individual markdown files. We drifted towards markdown because actually it was a kind of a more user-friendly format for it. But then we actually found that we wanted to express relationships that doorstop couldn't. So we created a new tool which kind of does a similar thing. It has the fundamental data about a statement recorded in a markdown document with some metadata section. It has references, and then it also has a graph, which at the moment is actually recorded as a graph.
So that's the place we just can export out as PDX file.
Yep.
Okay.
That is the format that Daniel presented before.
Yes, Daniel was giving you an example of that.
But I would guess, not speaking for you guys, but implying that again, also the TSF side and the tooling side and probably that format is work in progress.
Yes,
So
yes.
this is not a done deal. Anyone who has a good idea, again, this is going to be public in Eclipse in a couple of weeks, I guess.
It's public now.
It's public already, but yeah.
So at the moment, the only thing we haven't done is actually move the Git repository to Eclipse's own, but it's pointed to it from there. You can see that the documentation there has got a link to the repository as well. You can have a look at it.
And then one of the things that I hope we can do, just again, this might be very particular for certain use cases like ours, but what I mentioned, a bunch of assertions and evidence templates for because you Rust, let's call those libraries of assertions. I hope in our working group in Eclipse, for example, we can put together a bunch of those libraries. This is the Rust assertion library. You can use that templates. This is the one for Eclipse Project, etc. That would be huge, because if we had something like that, you get whatever coverage of that tree just by pulling in those assertions and fixing the details.
So I will go back to the data format again. if you think you're talking about a graph,
Yes,
there's lots of toolings for some specific types of graph definition formats.
yes.
Where you can use to navigate, you can use to edit, you can use to, so, but if we are doing it in a different way, then we lose all that information that's out there.
So it all depends on what you want to do with the graphs. And one
Yeah,
of the
but-
reasons why our current format literally uses the dot language to express the graph, so to express the relationship to them. The individual nodes are described as markdown files, but the relationships are expressed as a graph. That means that you can feed that graph into any tool that can render or let you explore or play around with dot, and you're there.
Now you would have another 7 minutes to talk about Rust.
We'll be quick. Do you want to start extolling its virtues, and then I'll put my slides?
I didn't really prepare structurally for this,
Maybe-
but I can tell you just maybe while Paul
Oh,
is
sorry,
looking.
just a second.
Just shortly stop.
Yeah, we'll stop, we'll
Oh, that's okay.
basically put the rest stuff in its own little recording window
Yeah, I need to.
and not